Hello everyone, I am Shiv Prakash, Research Scholar, Department of Electrical Engineering, IIT BHU, Varanasi. Let's start the session for today. First question I have taken from the concept of supernode. The circuit shown below, V1 is equal to 60 volt is given, and there are two dependent source. One is the voltage source, second one is the current source. It's asking how the power delivered by the 16 volt source. It means this volt, how much power delivered by this source. Then we have to find the current of this. I draw the circuit, same circuit clearly. You can see. This one is V1 equal to 60 volt. This is 20 ohm plus minus 5 I. I is current flowing through the 20 ohm resistor. This is the current source. So it is V1 by 4. This is 5 ohm resistor. Here is two nodes. This node, second node, this node. There is only voltage source connected between these two nodes. It means this type of a connection nodes is noted as a super node. If there is only voltage source between two nodes, then you can't find the current easily to what amount of current flowing through it, because of there is not resistor. You can't apply say KCL directly. Suppose this one is a V1, this one is a V2. If you want to find the current V1 minus a V2 divided by a sum, you have to find some resistance. Then you can say the current, but there is not a resistor. Only the voltage source is there. In that type of connection is seen as the super node problem. In this case, you have to check the current. In this case, current is flowing from this side and this side, both are the same because of this these V1 V2 voltage source. That's why the overall current flowing through uh, supply by this voltage source would be zero current. That's why same if the current is flowing through this is suppose I, then same node is current is going divided this one I, after that this current divided into two part. You have to neglect the current flowing between them. That's why if you apply the KCL in this case, nodal analysis, then you have to write the both node at a single equation, because of the same current is divided between I, this current and this current. There is a node meaning of this current in this branch. If you know this current, then you can say easily this current is divided between these two. But if you can't find the current between this flowing through this branch, then same current you can find by these two. If you add these two current in this node, then you can say the total current KCL satisfied by these nodes. Suppose if I taken this current is I1, this current is I2, this current is I3. Then what is the KCL here at node V1? KCL I, or you can say this is a incoming current. Incoming current if you taken as the positive, then all outgoing is be negative. I negative is this is small I. Then this current is I1 minus of I1 is equal to 0. Simply by the KCL, if you take it as the current of I1 like that, then you can say this is the equation. Same I1 divided into two part. I1 is equal to I2 plus I3. Then you can directly retain as minus, in place of I1 you will directly write the I2 plus I3. It means the total KCL is I minus of I2 minus of I3 is equal to 0. It means you can write the same equation in a single equation for the two node because of this only. Because you can't find the current between this branch. Then this branch current is divided into two parts, then directly you can write these two current. Then KCL will be satisfied at node 1 like V1. This is the concept of super node. Okay, it means simply if you can't find the current, if any branch, then simply you can add the branch current after that branch, after that node. Because of simply I1 if is divided into two parts, so you can directly add these two current to satisfy the KCL at node 1.
Sir, one doubt, sir. That
Yes, yes,
sir, 5 is there na for the current the that voltage 5 is there, right?
yes, yes.
So
5 is the voltage source.
yeah, so that 5 is not the current, right? That is the current, right? We have
No,
here.
no, this is the voltage. No, the plus
Okay.
minus is given.
Okay.
This
Oh,
is
yeah, that is
the symbol is the voltage source symbol. Is
okay. So but hmm,
yes, yes.
5 is the current, right, sir?
I is the current.
Yeah. So
5
we
5.
have the current, right?
Yeah, yeah. But this current I is depending on this current only. But this whole thing is the voltage source. This is not a current source. If there is a current source 5 pi, a symbol anything like that symbol, then you can simply take in this current. Then
Okay. Okay.
in this
Uh,
case, KCL is I minus of small I plus this current minus of 5 pi is equal to 0. This is the KCL, simple KCL. There is not super node in this case. But this is the current, not a current source. This is the voltage source. If there is a voltage source, then you can't find the current directly in this voltage source because there is a not resistance between these two nodes. Then what you can divide?
okay, sir. Thank you.
That's why this is type of configuration is known as the super node configuration. In this case, if you can't find the current between this branch, then same current you can add these two because of this current is divided into two parts. So simply add these two current. These two currents equal to this current. You can't find this current, then simply add these two current. Then you can say there's the KCL at node 1. Okay, like that. Let's try to solve this question by using super node. The same circuit I want to draw again to simplify this one. Oh, sorry. This is the current source V1 by 4 depending on the voltage. This is the voltage source. Current source, voltage source, depend voltage source, current source is simply defined by the symbol. If there is a voltage source symbol, then that one is the voltage source, depending on the current. In this case, this is the current source, but depending on the voltage, the symbol is the current source. Then you have to take this is the as a current source, not a voltage source. Same thing here. This is the voltage source. Okay, I is given as this one. Take note V1 here. This is the V2. Okay, KCL at node 1. Let this current is I. then incoming current take a positive, then I, outgoing is negative, minus this current V1 by 20. Okay, then after this simply add these two current. After that same current divided into two part, then this current is V1 by 4, this is the V1 by 4, and this current is minus of V2 by 5 is equal to 0. This is the KCL at node 1 in the super node configuration. You have to add the both node equation in a single equation, both node KCL in a single equation. V1 is same as 60, then you can put the value 60 here, then this will be I minus 60 by 20 minus 60 by 4 minus of V2 by 5 is equal to 0. This will be I minus 3 minus of 15 minus of V2 by 5 is equal to 0. And what is the V2 in this case? Suppose you have to find the I2, I for the power calculation. Now what is the I in this case? I is equal to V2 by 5 plus 18. It means I is equal to V2 plus 90 divided by a 5. Then we have to find the I2. How can you find I2? This is V1 and V2 in this configuration. V1 minus V2 is equal to 5I. This voltage minus this voltage is equal to 5I. Between two terminal voltage is given 5I. Then what is the I? This resistor is directly connected to parallel with the 60 volt resistor, 60 volt voltage source. Then what is the I? You can say directly I is equal to voltage source 60 divided by 20 resistor is 3 ampere. The V1 is 60 minus of V2. This is the 5 into 3. In this case V2 is equal to 45 volt. Put the value here V2. This is the 45 plus 90 divided by 5 is equal to 135 divided by 5. 27 ampere. By 60 volt source. Voltage and current, can multiply these two. 60 into 27 is equal to 1620 watt. Okay, it means if you want to solve this type of question of super node, simply write the KCL, both KCL in a single equation. Okay, but if you have confusion about this super node, then leave the apply for the KCL directly. You can use the KVL. If there is a super node, if you want to avoid by the super node, simply you can write the KVL in that case. KVL, it will be satisfy simply, and you can solve the question by KVL. Okay, how can you write? Let's I give this example by KVL and solve same thing. This is V1 is equal to 60 volt, 20 ohm. This is a current I, V1 by 4 plus minus 5 I. This is 5 ohm resistor. We have to take the current of I here. What is the I in this case? Is directly connected, then 20, 60 divided by 20, it will be 3 ampere. I is equal to 3 ampere. Then what is this voltage? 5 into I, it will be 15 volt, because I is equal to 3. V1 is 60, 60 divided by 4, it will be 15 ampere. Then I, what is the current in this branch? I minus 3, because of this one, 3 ampere is outgoing. Then what is the current here? I minus 3 minus this one 15 ampere. Then you can say this current is passing I minus of 18. Simply use the KVL in this loop 1. This is minus 60. Then this is plus 15, 5, 5, 15. Then this resistor voltage drop, 5 ohm resistor. What is the current? I minus 18. This is the 45 minus 45 plus 5, 5 minus 90 is equal to 0. Then I is equal to 45 plus 90 is equal to 135 divided by 5 is equal to 27 ampere. If you want to avoid the super node, then simply use the KVL in super node condition. You can get the answer same. Okay. Let's try for the next question. This question also have super node. These are two nodes, V1 and V2. You have to find the voltage V1 and V2 in this case. Again, you can say this current is divided into two parts, these two parts, and same this current is divided into again two parts. Then for the KCL, you can choose this current, and this two current. Okay. KCL at node 1. Take the all is the outgoing current V1 minus 3, V1 minus of 3 divided by 2 ohm resistor is there. then plus V1 by 3, plus then after here goes to here, then V2 by 2, plus V2 minus 2 divided by up 1 ohm resistor. This is the KCL in case of super node. You have to write the both nodal equation in a single equation. Okay, because of same this current is divided into two part. Okay, take a LCM is 6, and this is multiplication of 3. 3V1 minus of 9 plus 2V1 plus 6V2, sorry 3V2, this is 6V2 minus 12 is equal to 0. This 3V1, 2V1 is equal to 5V1 plus 6 plus 8. So 6 plus 3 is 9V2. Remaining part is 12 plus 9 is 21, minus of 21. If to go to the right side, it will be a positive 21. Equation number first. V1 minus of V2. V1 plus 9V2 is equal to 21. Then what is the V1 minus V2? This voltage. V1 minus of V2 in this case is equal to this voltage is 1 volt. Simply 1 volt. This is question number second. You can multiply by 5 in this question number second. Simply add 1 minus of 5 into second equation. Multiply 5 here, this will be 5V1 minus of 5V2 is equal to 5. Equation number 3, add subtract 1 minus 3, then what is this one? So 5V1 plus 9V2 is equal to 21. Second one is 5V1 minus of 5V2 is equal to 5. Subtract these two. V1 cancel out. 9 plus 4, 5 is equal to 14. V2 is equal to 16. Then V2 is equal to 16 divided by 14 equal to 1.143 volt. Then what is the V1 in this case? V1 is equal to 1 plus V2 is equal to 1 plus 1.43 is equal to 2. So this one is 143, not 2.143 volt. V1 and V2. Okay. Simply you can apply the KCL both node and write the KCL at a single equation, in a single equation, and solve this equation. You will get the final answer. Okay. The next question. Consider a circuit shown below. Find the voltage V1 and V2. Say we have to find the voltage V1 and V2. In this case, there is a resistor connected across to this voltage. Okay. The resistor connected, then don't worry. This resistor also have a don't mind, because of if you write a equation, then this current is flowing in the loop like that. This current is not considering by this equation, because of this current is same. This current is flowing these two, three only. Because of this, if you take the KCL as V1 minus V2, then V2 minus V1, then same. You get the cancel out to each other. Wait, I can do for those two. This 2 ampere is coming, then 2 ampere minus of outgoing V1 by 2. Suppose if you consider this resistor, then V1 minus V2 divided by 10 ohm, V1 minus of V2 divided by 10 ohm, then V2 by 4, this is in this node second 4, then this current is minus of 7 ohm, 0. Oh, sorry. Then you have to take the current equation for this also. Then minus this will be V2 minus of V1 divided by 10. Then this will be 7 ampere is equal to 0. You can see this both is simply reversible. It means both are cancel out to each other. Then no need to write this equation also. We have to simply add these two branch current, these two branch current, 4 current only. Then this will be a 2 minus of V1 by 2 minus V2 by 4 minus of 7 is equal to 0. Take LCM 4. This will be 8 minus of 2V1 minus of V2 minus of 28 is equal to 0. Then what is final answer? 2V1 plus V2 is equal to minus of 20. Equation number first. Another, what is the voltage of V1 minus V2? This is the positive negative, because of this is the larger line. That's why this is the positive, this is negative. Then in this case is the V2 minus of V1 is equal to 2, or you can say V1 plus V2 is equal to minus 2. You multiply by minus in this case. Sorry, V1 is right here, then I'll get this one. Or you can say this is V1 minus of V2 is equal to minus of 2. Because of V2 minus V1 is equal to 2, then V1 minus V2 is equal to minus 2. And V1 minus of V2 is equal to of minus 2. You can add this thing, then this will be 3V1, this will be 0 is equal to minus of 18, then V1 is equal to minus of 18. Oh, sorry, this will be 22. If you add, there is no change of sign. Minus of 22 by 3. This will be minus 7.33 volt. And what is the V2? V2 is equal to minus of 2. In this case, we take V2 is equal to V1 plus 2. If we add this one, then this will be a minus 5.33 volt. Okay, simply you can add a two equation in a single way. Then solve this one, you can get the answer of the supernode question. That question. Okay. Let's go for the next question. A voltage source deliver a 4 ampere when the load connected is 5 ohm and 2 ampere when the load connected is 20 ohm. The value of maximum power which source can deliver and power transfer efficiency when the RL is equal to 5 ohm. Okay. Simply there is a voltage source have a some resistor, internal resistor, then there is a resistor RL, load resistor. This is R, this is V. Suppose current is flowing I. In this case, you can say the KVL V is equal to I into R plus I into RL. Voltage drop between these two resistor. Then see the question. Question is given as the voltage source deliver 4 ampere of current when load connected is 5 ohm. If RL is 5 ohm, then current is 4 ampere. Then V is equal to, this is 4 ampere plus 4 into RL is equal to 5, 5 ohm. Then V is equal to 4R plus 20. Equation number second. And same thing is current flowing is 2 ampere when the load is connected as 20 ohm. Then V is equal to 2 ampere current plus I 2 ampere in load is connected as 20 ohm. Then V is equal to 2R plus 40. This is equation number third. Then subtract equation second minus of equation number third. Then V cancel out 0. 4 minus 2 is 2R. 20 minus 40 is equal to minus of 20. Then in this case R is equal to 10 ohm. R is equal to 10 ohm. Then what is the voltage? If you take this thing, voltage is equal to 4 into 10 plus 20, V is equal to 60 volt. We have voltage source, voltage and internal resistor. Then what is the maximum power? You know about the maximum power transfer. In the case of maximum power transfer, RL is equal to RS, or in this case is R, which will is a 10 ohm. Then what is the power divided to the RL is V square by 4R. Voltage is 60 into 60 divided by 4 into 10. This will be 10, 6 60.
Sir,
Yes,
I have a inquiry about the upper side. Sir, can you tell me how? Mm, yes, the third line. The third line was V equals to 4R plus 20.
yes,
So, so how can be the next line V equals to the 2R plus 2 into 20?
yes. Actually, this question is given as 4 ampere is current flowing when RL is 5 ohm. This is the case first. Then in this case, I written as the V is equal to 4 into 4 ampere R plus 4 ampere into 5 ohm resistor. Second case is current is flowing 2 ampere and when the load connected is 20 ohm. This is the case second.
Okay. Thank you,
Then
sir.
okay, welcome. In this case, if you solve this one, 6 ja 10 6 ja is 60. 60 into 6 is 360 divided by 4 equal to 90 watt. Maximum power is 90 watt. Yeah, so asking about the efficiency. Suppose same thing, if the RL is 5 ohm, then what is the efficiency in this power transfer? Efficiency, you know about the efficiency is equal to power output divided by power input. Output is I in square into RL is output power. Input power is this one, voltage source into current I. If there is a 5 ohm resistor, then RL, what is the current? Current is flowing 4 ampere. Then what is the power? 16 into RL is 5 divided by what is the total power? 60 volt into, in that case, I is equal to 4 ampere. This is a 4 ampere current. That means 4 into 4 is equal to 16 into RL. Load resistor is 5 ohm divided by a voltage source is V is 60 volt, and the current is 4 ampere in the case of 5 ohm resistor. This is a 20 divided by of 60. This will be 0.3333. If you want efficiency in percentage, then simply multiply by 100. Then this will be 33.33%. This is the power.
Sir, that 0 equal to 2R minus 20, sir, that equation from where it came actually?
Actually, if you subtract equation number second minus equation number third.
Okay, got it, sir.
This.
Sir,
Yes, yes.
sir, generally, when maximum power transfer has been done,
Hmm.
they say no, sir. 50% efficiency will be there, no, sir.
Yes,
Generally, we say.
yes, yes, sir.
Then why here only 33.33%, sir?
In this case, also 50% efficiency. If you taken this case, RS is 5 ohm. Na RL. Sorry, RL is if you take 10 ohm resistor. If you take a 10 ohm resistor is RL, in this case you get the final efficiency is 50% only. 50%. And final maximum efficiency is maximum power is 90 watt. Okay. But in the question is given the what is the power transfer efficiency when RL is equal to 5 ohm. It's not saying
Oh,
about the 10 ohm
yes,
resistor.
yes, sir.
Ah,
Now I understand, sir. Thank you,
okay,
sir.
okay, okay. Maximum power is at 10 ohm resistor, not 5 ohm resistor, but is asking efficiency at 5 ohm resistor. That's why in this case the power efficiency is 33%. Okay, let's check for the next question. For the circuit shown in the below figure, the current through the 1 ohm resistor between terminal X, Y using Thevenin theorem will be. Okay, asking about the current flowing through this resistor. Okay, then for the finding Thevenin theorem, there will be a I think my screen is stopped. I think. Okay, wait. I connect again. Wait, there is a problem in connection. Okay, everyone. Screen is visible for all. Okay, yeah, it's running. Okay, this question asking about the you have to find the Thevenin equivalent in this case. Simply you can disconnect this register and apply the PI method to find the Thevenin equivalent because of there is a dependent source.
Sir, your mic is not here.
Oh, sorry. Okay. Forget to on the mic. This 2 V node, this will be 21 volt. V naught is 1 ohm resistor, and there is a current source also given, which is a 5 ampere. Then another current resistor. Both are the 21 volt battery connected to both end. Oh, sorry, you have to find the this is 6 ohm, this is 5 ohm. We have to find Thevenin equivalent across this resistor. Simply apply the VI method. Current is I. What is the voltage? Simply V volt. What is this volt in this node? This is the plus minus 2. This is the 2 V naught. This is 2 V naught. What is the V naught? Simply you can apply the KVL here to find the V naught in this case. Because of all the element voltage drop is given. This is a V naught, this is 2 V naught. This is a minus of 21 plus of V naught plus of 2 V naught is equal to 0. In this case, V naught is equal to 21 divided by of 3. This will be 7 volt. Then 2 V naught is equal to 14 volt in this node, and V is this node. Then you can apply the KCL. And node V in this node. Then what is the incoming current is I. Then outgoing current is this 2. V minus 14 divided by of 6 ohm resistor plus V minus of 21 divided by of 5 ohm resistor. You can take the LCM as 30. This is the 5V minus 70 plus 6V minus 126. This is the 30i. If you multiply this one, 30i is equal to 11v minus of, if this is both are the negative, you can add this one 196. And what is the v? V is equal to 30 divided by of 11i plus 196 divided by 11. It will be v is equal to, divided by it, this will be 2.72 I plus this is 17.8. And you know about this one, this is the RTH, this is the VTH. If RTH, VTH if you know, then simply make a circuit. RTH, this is the VTH, is equal to 17.8 volt. RTH is equal to 2.72 ohm. Then add that resistor 1 ohm. You have to find the current I. What is the I? I is equal to voltage V by R. Voltage is 17.8 divided by F, total resistor 2.72 plus 1. This will be a 17.8 divided by F, 3.72, 4.78, 8 ampere. Okay. If you want to find the Thevenin equivalent, then simply add VI method. You will get the final Thevenin resistor and voltage together. Okay. Suppose that mention in the question is the Thevenin theorem. Then how can you find? Simply apply KVL. Same question, if the Thevenin is not mentioning in the question, then at the same question I will get another solution. The dependent voltage source, this is the current source, no, 1 ohm, this is 6 ohm, 5 ampere current plus minus 2 V naught, this is the V naught, 1 ohm resistor. Same thing, we already find the V naught. V naught is equal to 7 volt from previous question. This is same, you can apply KVL here. Then we have to find the current at 1 ohm resistor. The current is flowing like that. What is the voltage drop? 1 I into 1. I into 1, it means I volt. Then you can say this voltage, this node voltage is I. This is the this voltage drop 2 into V naught. 2 V naught is equal to 14. Then simply you can apply the KCL in this node. I minus 14 divided by of 6 outgoing, then incoming all as the, suppose take outgoing, then so all the is positive, plus I minus of 21 divided by 5. You can take as a KCL, LCM. Also this will be 5 minus of 70 plus 30i plus 6i minus of 126. This will be 5 plus 6 11 plus 30 41i 41i minus this is 126 minus 20 is equal to 196 is equal to 0. What is the I? 196 divided by 41 is equal to 4.70 ampere. For solving the network problem, then try to let for the some variable as minimum as possible. If you take the if you let the number of variable is more, then you have to find the number of equations to solve that variable. Then to reduce the number of variable as less as possible. In this case, I taken as only one is I is the variable and solve the question all question by taking a one variable. Suppose if you take the 2 to 3 variables, suppose you take this current also I1, this current I2, okay, and then here is the given as the V naught. Suppose you can take another I3, then there is a I3, I1, I2 and I4 variable is there. Then you have to find the 4 equation. Then after you have to solve these 4 equation to get the final answer. That's why take the let the variable as minimum as possible to solve the network problem. Then you will get the answer faster. Okay. Don't let the more variable.
Sir, one question, sir.
Yes, yes.
For the this from Thevenin theorem and from the classes, we know that like we sort the independent sources and then do one calculation and then again remove the remove the load and do one more calculation. But here directly like we applied and we got the answer. So like which approach is better?
This is a pros now because
Yeah,
of
this looks better. So that's why.
this is better. You can if there is a dependent source,
Okay.
because you can't be sort the dependent source or you can't open dependent source. All the
Oh,
independent source you can sort or open for the finding the RTH or
okay.
RN. But a dependent source is there, then you can't be sorted. If you can't sort the dependent source, then for the finding the uh, resistor equivalent resistance like Thevenin equivalent or Norton equivalent, then there is a problem. So for the better way, simply apply the VI method. Use voltage, remove that resistor and use a voltage source and current source and find the V. If there is a combination of I plus something, and this is the RTH, this is the VTH. You will get the RTH and VTH. You can also find the IN, Norton's by dividing the VTH and RTH. Simply a single equation, simple method. You can get the all the solution. A single method. There is no need to try to find the short circuit and open circuit. First to find the resistor, then after you have to find the VTH by giving the open circuit voltage. Then you will take the long method. Okay.
Yes, sir. So we can do directly for like the independent sources also directly apply KCL or KVL and get the answer. Okay.
Yes, yes. For the independent source, there you can use that method. But if there is a dependent source, then use this method. This is the better solution for all.
No, sir. My question was like for the independent sources also we can apply directly KCL and get the answer, right?
Yes, yes, yes.
Okay. Okay. Thank you.
Next question is given as a current in 3 ohm resistor branch. This 1 ohm resistor is here. 1 ohm current is flowing, entering, and divided into two parts. Then There is a combination of resistor, and we have to find the current in this branch. Okay, this is a 4 ohm, 1, 2, 3, 4, 5 ohm. In this case, suppose there is a 1 ampere current is incoming, then same 1 ampere current is outgoing. That's why given like that. And then we have to find the current in middle branch. Then suppose take as this is the X, and what is this ampere? This current. 1 ampere is coming, X is going here, then what is this one? 1 minus X. Then take this is the Y ampere in branch of 3 ohm. Then what is this current? 1 minus of X minus of Y. Okay. Then 1 ampere is also going here, leaving here. Then what is this current? This current is, or you can say this is the X current is coming, then Y current is X here, Y here, then this current is X plus Y, and this is the 1 ampere is remaining because of the this current is 1 minus of X minus of Y, this current is X plus Y, then only 1 ampere current going through it. KCL is satisfied in this condition. Okay, if KCL is satisfied, then we have to try to solve this question. If your assumption is if KCL is not satisfied, then you have to check at every point it should be satisfied. Make two loops, loop 1 and loop 2. In this loop, current direction is this one, then this is 2, 1 minus X, KVL.
Sir,
Yes.
can we use a current divide rule here, sir? 1 amp into 2 ohms by 1 plus 2 ohms, like that.
No, can't use no, because of there is not a parallel path. You can't say the 1 ohm and 2 ohm is a parallel to 1 ampere, because of this point is not same point.
Okay, sir. 3 ohms in between, like that's why you can say like that, sir.
Yes. If this is the sorted, then you can say that this is a current divider. You can simply apply. But there is a register, then you can't apply the current divider here. Current divider or voltage divider only apply where the series and parallel combination. Directly series and directly parallel combination.
Yes, sir. Now I understood.
No. KPL in loop 1. Then what is this one? 2 ohm resistor, current is 1 minus X, and this is the plus 3 Y. Then this is the reverse direction is there. Current is flowing here, but loop is coming from here like that. That's why this is a negative of 1 ohm resistor and X current. This is the 2 minus of 2X plus of 3Y minus of X is equal to 0. This is minus of 3X plus 3Y is equal to minus of 2. You can multiply minus here, then this will be 3X.
Sir,
Yes.
in 3y, actually, sir, uh, 3 into y minus 1 minus x minus y, like that we shouldn't take, sir.
No, the high rated at this loop is here only. This loop. It means 2 ohm resistor, 3 ohm resistor, and 1 ohm resistor. I taken as the 3 ohm resistor current is Y. I taken this current is flowing Y. That's why I written as 3Y. 3 resistor and current is Y.
Yes, sir. Now I get it, sir. Yes.
Okay. Then again KVL. in loop second. So started from here, then this will be 4 1 minus x minus of y, then this is reverse direction, then this will be minus of x plus y, then this is also reverse direction of 3 ohm, then this will be negative minus of 3y is equal to 0. Loop is completed. Then this is a 4 minus of 4x minus of 4y minus of 5x minus of 5y minus of 3y is equal to 0. Then 4x minus of 9x 4y minus of 5y minus of 3y minus of 12y is equal to minus of 4. This will be 9x plus 12y is equal to 4. Equation number second. Then simply multiply 1, equation number 1 into 3. Yeah, you can multiply with 4 also. We multiply 4 here, 4, then simply add equation number second. You multiply 4 here, then what happens? This will be 4x minus of 12y is equal to 8. Then this equation is 9x plus 12y is equal to 4. Simply add both. 9 plus 4 is 14x is equal to 12. Then x is equal to 12 by 14. 0.8571 ampere.
Up
Yes.
12x, no, sir. In the equation 1, if we multiply with 4 means.
Oh, this will be 13. 13.
No, sir.
Huh?
3x minus 3y equal to 2. We have multiplied by 4, no, sir.
Okay.
So,
Okay. Sorry. Sorry.
12x.
So yes, yes, I understand. Then x is equal to 12 by 16.
Sir, no, sir.
Again.
In 3x minus 3y equal to 2, we have multiplied by 4, no, sir. First equation. We have. Yes, sir. Yes, sir. Correct.
Okay. Thank you. This will 0.57 ampere. Put the value of x in any one equation. Suppose if you take this one equation, then 9 into 0.57 plus 12y is equal to 4. Then y is equal to 4 minus of 9 into 57 into 0.57. This will be 5.13 divided by 12. This will be 0. Sorry. Y is equal to, this will be 0.0, this will minus 0.0942 ampere. Okay, but in the option is not given as a negative, then it means which one you taken as the direction, then that direction will be reverse direction actually. That's why you have to put the y value as 0.095 ampere, and your taken direction will be reverse. Then this y will be like that. Okay. If this type of question, if the question is asking in the particular register, then find directly that resistance current. This current is the Y. Then there is no need to find the X ampere. You can directly multiply by this one, multiply by 3 as a 3 in this equation and subtract this one, then X part is cancelled out, will directly get the value of Y. There is no need of to calculation more in this case. Okay, directly you get the final answer Y. In this type of question, directly find that value only, not another value. Then you can save the time in the examination. Okay, if the direction is also given in the question like that, same if a direction is given in the question, in that case you have to put the negative value in the final answer. But here is not direction is given in the question, then you let the direction, then that direction may be reverse. That's why there is you have to put the final is the positive value, not a negative value, because of the you taken the direction. If you take the direction, then that direction may be reverse. But in the question, if the given direction in the question, then you can't be reverse that direction. You have to find the current related to that direction only, and you have to put the value according to this direction.
Sir, I have one doubt, sir. Actually,
Yes, yes.
assignment 3 and assignment 5,
Uh,
you are giving that without the multiple choice questions, right? Uh,
okay.
my answer is also correct, but the sign is only different. But now you are saying that even though the direction is we've only decided, na, but the mark is nothing but zero, sir. What we can do, sir? Tell me. So we can assume it any direction, right?
Yeah,
Numerical value is right, but sign only different.
yes, yes. If the
But
question,
awarded is nothing but zero mark.
okay, okay, okay. I understand your doubts, but in the question is given direction, then you have to put the answer according to that direction only.
No, sir.
But in
In
the
that they didn't mention the direction at all. This is nothing
direction,
but without multiple choice question. Just they given the fill in the blanks, right? So
yes,
I
yes,
solved it my own direction. I get the numerical value perfectly. Okay. Once the
okay.
answer is distributed, then only I checked my numerical value is correct, but the sign is different. But awarded is zero mark.
Is it
So I
okay?
got
Okay,
30 marks in the fifth assignment.
okay, okay. I'll check the question. Which one question? Take about.
I'm not remember. I pointed out and I sent a mail to you, sir.
Okay, okay. Send the coordinated mail. Then check.
Okay. Thank you, sir.
Yeah, no problem. The next question is determine the equivalent resistance faced by the voltage source if the S1 is closed and S2 is open. We have to find the equivalent resistor faced by the voltage source even between these two terminal. We have to find the resistor. Also given as the S1 is closed and S2 is open. If the S1 is closed and S2 is open, then what the circuit is looks like that. This is the open circuit. Same circuit is looks like this is the short circuit. This is open circuit. And this is 12 volt. This is 2 ohm, 3 ohm, 3 ohm, 2 ohm. 10 ohm, this is also 10 ohm, this is 10 ohm. Okay, if there is a short circuit, it means these two resistor is connected in parallel and these two resistor is connected in series. Then what the next circuit diagram, if we add the two configuration, these two summation is 12 ohm. Okay, this is the single point resistor, below side is 5 ohm. If these two is sorted, then same thing you can write like that, a triangle. Simply for your understanding, I write these two in triangle form. Okay, this is the 3 ohm, this is 3 ohm, this is 2 ohm, 3 ohm, 3 ohm. In this case, you can see these three resistors are connected in delta connection. Then you have to simplify in star. If you take a star, then what is the resistor? Both all of the resistor is equal value is 3 ohm. Then you have directly divide by 3 for conversion in star. This is the 1 ohm, this is 1 ohm, this is 1 ohm. Okay, then our circuit looks next. This will be gone because of the triangle. This circuit looks like that. This is 12 volt, 3 ohm, this is 3 ohm, this is 1 ohm, 1 ohm, and 1 ohm, this is 5 ohm, this is 12 ohm. Okay, these two are connected in series, these two are connected in series, then these two are connected in series. After that, these two are connected in parallel. Okay, I have draw again the circuit. These two are 4 ohm, these two are also 4 ohm, then another resistor is 6 ohm. Then these two are connected in parallel. What is the combination of these two? 4 into 6 divided by of 10. Sorry, here is some mistake. This is not a 3 ohm, this is a 2 ohm resistor. This is 2 ohm resistor, 2 plus 1 is 3 ohm. Combination of these two are 6 into 3 is 18 divided by of summation of this 9 is equal to 2 ohm. Okay, then these two are connected in simply parallel combination. Four ohm, 2 ohm, 12 ohm, 5 and R equivalent, these two is 6 parallel with 12. 6 into 12 divided by of 18 is equal to 4. Okay. Next question is asking about the Norton's equivalent between A and B. We have to find Norton's equivalent. Sorry. For the Norton's equivalent, simply apply a same VI method. Two terminal A and B. This is the 1 ohm resistor. This current is given as I1. This is a voltage source depend on the current of I1. This is 2 ohm resistor. This is 2 volt. Okay, simply apply a VI method. Voltage source and current I is the voltage. In this case, you can see this voltage source is directly connected to this 1 ohm resistor. Then what is the current flowing through it is V by 1 ohm resistor is equal to V, and same is this one is I1. It means I1 is equal to V for this question. This because of this voltage directly connected to the 1 ohm resistor. Okay, this current is I, this current is I1. Then what is this current? I minus I1. Then simply apply a KVL in this loop. Okay, starting from this one, minus of V plus this voltage drop 0.5 I1 plus this one 2 ohm resistor and voltage drop of I minus of I1 plus 2, this voltage source. I1 is same as V, then minus of V plus 0.5 V plus 2I minus of I1 is equal to V, then this will be minus of 2V plus 2 is equal to 0. Then this will be minus of V plus 0.5, it equal to minus of 0.5 minus of 2 is equal to minus of 2.5 V plus 2I is equal to minus of 2, and what is the V? V is equal to 2 by 2.5 plus I plus 2 by 2.5, then V is equal to 0.8 I plus 0.8. This is the RTH, this is the VTH. But in the question asking about the Thevenin, then you know about the Thevenin resistor is same as the or Norton's resistor. It will be 0.8 ohm, and IN is equal to VTH divided by of RTH. 0.8 divided by 0.8, it will be 1 ampere. And what is the circuit? Circuit, a current source parallel with the resistance. This is the circuit. Resistor current is 1 ampere and resistor is 0.8 ohm. This is the circuit of Norton's equivalent circuit. In this case, I think this is the answer. Okay.
Sorry, sir, I missed something.
Okay.
In
Okay.
question, there are two loops actually, right? We took only one loop. Or is
No,
it
I taken only one loop.
okay, sir? How we can take like only one loop? Actually, two loops are there, right?
Yeah. If you have two variable, then you have to find the two equation to solve this. But I directly find the I1 by this one. This is the I1 is directly connected to this one. V directly then you can say that this is also a loop, one loop, and this loop is directly V1. V is directly to I into 1. It means I1 is equal to V. This is also a loop, but this loop I directly solve by using uh, this voltage source is connected across the 1 ohm resistor. That's why
Okay, got
this
it. Got
this
it.
this current is directly find. This current directly find, then apply the KVL in my outer loop.
Yes, sir, got it.
Yeah,
Thank you.
you can apply KVL here also. Here also is lot of the loop. Three loop. You can check the three loop in this question. But you have to minimize as minimum as possible taking the equations to solve, because of the equation solving is taken the time. You take the time to solve this equation. That's why try to take as minimum as possible equations to solve this.
Sir, one general question, sir. Like
Yes.
in exams, sir, like how many questions will be there? And like 3 hours time is there, right?
Yes. Yes.
So how many questions we may have to solve? Like 30, 40 or some numbers.
Actual,
Like
it will vary actually depending on the questions pattern. They can change also. This is defined by not me only. That's why I can't say directly how many questions there. But that question is same like that. Only. Which one solving in the session, almost session. But exact
yes,
number
sir.
of question I can't say directly because also don't know about that.
So like we need to accordingly practice, right? Like the questions so that at some time we are able to finish a problem. So we have to practice accordingly, right? So that's why I ask.
Okay, okay. Okay, I try to find the previous year's questions. If they provide me, then I will say.
Yes, sir. Please, thank you, sir.
Okay. Next questions. If you see here, there is another the super node problem. Okay, this voltage source is connected to these two nodes. Between these two nodes, there is not a resistor between them. Okay, if you take a current, any select the current of I here, then you can apply KVL here, but you can't apply KVL here. In this case, KCL. In KCL, you can apply here, but this is also a problem. You have to find the KCL two nodes. It means this current is provided in this current, and this current like that. Then you can't say directly. Okay, in this type of question, try to solve as given by the question only. Suppose this is the voltage is given in the question. Okay, Then what is the current in this question? Voltage is given. Then in this node voltage, suppose this is the ground, this voltage is V because of this thing. 3 ohm resistor voltage drop is given V. Then what is the current? In this case, V by 3. Same thing, current flowing through this. Okay. And this current is 1 ohm resistor is 1 ampere. Then what is this current? Okay. Or 1 ohm sorry, 1 ampere current is divided into two parts. Suppose this one. Then you can apply the KCL at this node. Because of this one, you can find the voltage here is 6 volt. Because of this is connected to ground. This is the 6 volt. Then simply apply the KCL. Don't go for the super node. Simply apply KCL where the super node is not there. That's why simply apply KCL here. Then 1 ohm resistor, 1 ohm current is flowing, 1 ohm incoming, outgoing is V by 3 plus again V minus of 6 divided by a 6 ohm resistor. This is 6 volt. Simply this is 0, we will get the final answer. LCM is 6, this will be 6 plus 2V plus V minus of 6 is equal to 0. Sorry, here is some mistake. Incoming current is positive 1, then outgoing current is negative. Both are negative, not positive. Okay, if negative, then this will be positive. This will minus of 3V is equal to minus of 12 V is equal to 4 volt. Okay, don't worry about the super node. Simply search that node where you can apply this KCL or where you can apply the KVL. Then search that loop. Okay, same question if you go for the taking the uh, variable like I, this one, this is the I1, then you can apply the KVL here, then apply KCL here for two variable, then you have to find the two equation, that two equation you can solve. Okay, if this is a I1, then this is also V by 3 plus I1 because of this current is flowing. You apply the KCL here, then you get the final KV here. I mean, there is many types, many methods to solve this question by avoiding the supernode also. Okay, but there is no need of this one. Simply apply KCL. Next, the power delivered by 12 volt source in the watt for the following network. They are asking the power delivered by this one. In this case, you can apply the this node and apply the take the voltage and apply KCL at that node, then you get the all the current here, here and here. Then after this current emitted at this point, then you will get the this current. But they is asking about the 12 volt resistor, 12 volt voltage source power delivered. Then simply take this one as the I, because of you have to find this current. then let this current only. Which one you have to find? Then directly find this value variable for you. If this is I, then what is this current? I is meeting this point. Current is 4 ampere here. Then this one is I plus 4. If this is the I plus 4, then 1 ampere is here and 4 ampere is going there. That's why this is the I plus 1 ampere is current flowing through it, this branch. Then what is the loop where you can apply the KVL? Then you apply this loop only. You can't apply the KVL in this loop because of this voltage drop is not known. Then don't apply this loop. Apply where the voltage source or resistor is there. Current source I have not a voltage drop given in the question. That's why you can't be apply the case KVL here. For applying the KVL here in this loop, then you have to first find the voltage drop, voltage across to the current source. So please avoid this type of thing. Simply apply KVL where the voltage source and resistor is there. Starting from here, minus of 12 plus this is 2 ohm resistor, I plus 4. Then here minus of 6 ohm, because this is negative first, minus of 6 plus 1 ohm resistor, current is flowing is I plus 1 is equal to 0. This is minus of 12 plus 2I plus 8 minus of 6 plus I plus 1 is equal to 0. I 2I plus I is equal to 3I. Then 12 6 is both are negative, that will added is 18 minus of 8 is equal to 10 minus of 1 is equal to 9. Then this will minus of 9 is equal to 0. Then I is equal to 3 ampere. What is the voltage power? Power is 12 into I is equal to 3. 12 into 3 is equal to 36 watt. Okay. By a single equation, single variable, we will get the answer of this question. Okay. No need to take another 2 or 3 equations to solve this.
Sir, can you scroll up again to the question number 7?
Question number 7. This one?
Sir, the answer.
In this case, its answer is 4 ohm. Okay.
Yes, sir.
Oh, thank you. Determine the Norton's equivalent current in ampere for the following circuit. Oh, simply asking about the Norton's equivalent current. Okay. There is a all independent source, not a dependent source. Then we have to find the Norton's equivalent current. For the current, you have simply short circuited. If the short circuit this one, we have to find this current is IN. If this is a short circuit, then this resistor is have no meaning, because of this is also short circuit. This is directly connected to this short circuit path. That's why there is no current flowing through this 8 ohm resistor. That's why this is the this is not meaning of this one. Okay. Now redraw the circuit and find the answer. This is the 1 ampere. This is given as 2I, and this current is I. 2 ampere, 2 ohm. This is the 10 ohm resistor. Okay. You have to find the IN. There is a resistor, but this resistor have no meaning. That's why I remove this one. This current is 1 ampere. Okay. And this incoming current is 2I and leaving current is I. Then what is this current? 1 plus I. Okay. After that, 2I is outside is there. Then what is this current? This current is 1 minus of I. It means same current is IN. Then you can directly says that IN is equal to 1 minus of I. We'll get the one equation. Okay. Another, you can apply KVL in this loop. This is the current flowing direction. This is the minus of 2I plus 10 of 1 plus I is equal to 0. There is no resistor. Then minus of 2I plus 10I is equal to 8I plus 10 is equal to 0. Then what is the I in this case? I is equal to 1 minus of IN. Put the value here. 8 1 minus of IN plus 10 is equal to 0. 8 minus 8 IN plus 10 is equal to 0. Then IN is equal to 18 divided by of 8. 2.25 of ampere. Okay. Simply asking only the single register. Okay. Oh, these two is the same, I think. Okay. This is the final answer. Final, I want to stop the session here. Next session will be on next Tuesday. Thanks to all for joining this one. Okay, everyone.
Thank you, sir.
Okay.